So this is the rest of section 1.4. So we've talked about how to solve just regular equations, what I consider very kind of non-word problem, non-formula type equations. Now we're going to look at what's called a literal equation. So a literal equation is something that is equation in terms of different variables, and it usually has an actual meaning in life. So things like area of a triangle is a literal equation. Equations that you work with in a lot of your science classes are literal equations, where those variables have a little more meaning than maybe they do with something where it's just 3x plus 2 equals 10 and you're trying to solve it. So when we write a literal equation, we say that it is solved for a particular variable in terms of a variable. So with this one, this first one, and this may look familiar to you if you're looking at this equation going, I think I maybe saw it at one point in my life. This is the Celsius Fahrenheit conversion equation. So you would have probably seen it in a science class. So this one we would say is solved for C, meaning C is by itself, and it is in terms of F, meaning that's the variable that's on the other side that you would actually plug in. So if someone said it's 85 degrees Fahrenheit, what does that mean for Celsius? You would plug in your Fahrenheit temperature for F and then basically do the quick arithmetic or use a calculator and figure out what's the Celsius conversion. But oftentimes when we're working with equations like this, we don't want it necessarily solved for the same variable. We want to rewrite it. What that means is I need to isolate a new variable. So when it wants me to rewrite this in terms of F, what this is saying is I need to get F by itself. I need to figure out what will this look like if it's F equals instead of C equals. So I need to undo it. I need to get it totally alone and isolated. So we kind of start working outside in, I guess, is the best way to say it. I need to get rid of this 5/9. The way I get rid of a 5/9, or in other words, do the inverse to get it to the other side, is I'm going to multiply by its reciprocal, which is 9/5 on both sides. What that does is it takes that part away from the F side. So now I have 9/5 C equals F. I don't need the parentheses anymore because I got rid of what was in front of the parentheses. And you might be watching this and going, why didn't she distribute? The reason I didn't distribute is when I start multiplying 5/9 times different things, it's not going to get any better. But if I can move it to the other side right away without distributing, it kind of keeps it a little neater. And then finally, again, I need to get F by itself. So I need to get rid of the minus 32. So to do that, I do the opposite, which is add 32. And this is actually my answer. It's not like an equation where I ask you to solve and in the end you get something like, well, x equals 5. Instead, I want it rewritten. The goal was to get F by itself. So now I have this Fahrenheit equation in terms of Celsius. So if I'm in a science class and now I'm going the other way and I say, well, it's 25 degrees Celsius, what's that in Fahrenheit? I can plug that Celsius in right away. We do this a lot in math classes, especially when it comes to graphing lines, rewriting lines. So that's what this one is. This is we call this standard form, when your x's come first and then your y's and then your equal sign and then your number. We want to get x by itself. So again, to get x by itself, I kind of work with what's away from it right now. I need to get rid of this minus 5y because currently it's plus 5y, so I'm going to do the opposite. So I have 3x equals, and I can write it as 10 minus 5y, or I can write it as negative 5y plus 10. The 10 is positive, the 5y is negative. They cannot combine because one has a variable and one doesn't. And then I need to get rid of the 3 that's in front of the x, so I'm going to divide everything by 3. You can do one big division bar, or you can do individual dividing as long as everything is divided. So you can leave it individually like this. You can also write it as 10 minus 5y, put a big division bar, divide by 3. But either way, my x has been isolated, so now I have solved for x. Show you a couple other ones here. So this one is a trapezoid area formula you should be familiar with from geometry or even sooner than that. So this is we want to isolate B1. So let me get my cursor here. We want to get this by itself. So the first thing I want to get rid of is what's in front. So I'm again going to multiply by the reciprocal. So I'm going to have 2a over h. That's what I get when I multiply this side by 2 over h. On this side, this is all gone. I don't need the parentheses anymore because I got rid of what was in front of the parentheses. And again, distributing would have made it worse, so kind of multiplying by the reciprocal right away gets rid of that. And then I want to get b1 by itself, so I'm going to subtract b sub 2. This is the bases of a trapezoid. If you can't remember what B1 and B2 meant, it meant the bases of the trapezoids. And that is solved for B1. I've got one more. This is a really quick one. It wants to get R by itself. I want to show you a shortcut with this. So R is in the middle. It needs to be by itself. It's currently being multiplied by P and T. So to get rid of that, I'm going to divide by P and T. And I can do it all at once because it's all the same operation. So it is perfectly legal just to do one division. And that gets you R by itself. And again, that was my goal. This is like a money-based equation, solving for like interest, like with a loan, something like that. So we're going to look at a few word problems. Oh, went too far. Start with this. We have a rectangle where one side, rectangle 1, I'll just call this rectangle 1, has sides that are x plus 4 on one side and 3 on the other. Doesn't matter which one's which. And then rectangle 2 has 2x minus 7 on one side and 2 on the other. What we know about them is they have the exact same area, and we're trying to figure out the dimensions of the rectangle. So area of a rectangle is very quickly just length times width or base times height, just multiply the dimensions. So rectangle 1 would have an area of 3 times x plus 4. Rectangle 2 would have an area of 2 times 2x minus 7. And we know they're the same, so that means they are equal. So I'm putting an equal, I'm turning it into an equation because I know that they are equal. I'm going to distribute the 3 through. I'm going to distribute the 2 through. So when I distribute, I get 3x plus 12 on the left. And then when I distribute on the 2 on the right, I get 4x minus 14. Turning it into something that we just did in the previous video, getting all the x's on one side. So I'm going to subtract 3x on one side and then on the other. Now I'm going to add 14 on one side and the other. So we get 16 equals x. Once we know what x is, again, you want to make sure you actually answer the question. So the question wasn't what x is. The question is, what's the dimensions of the rectangle? So if we take this 16, and here's where you do like a substitution and plug it back in, 16 plus 4 is 20. So that means this rectangle must be 3 by 20. This rectangle, when I do 2 times 16, that's 32 minus 7. 32 minus 7 is 25. I have something wrong here, and I'm not sure what I did wrong. Hold on. It's 14, 3x. No, that's right. I'm not sure where I'm goofing up here. So I get 25. Hold on. Let's see. 4x minus 14. 3x plus 12. Add 14 to the 12. I get 26. Hello. Sorry. I'm sure many of you are watching this video going, she's lost her mind, which I probably have. 26, not 16. Hello. So that's 30. So that rectangle is 3 by 30. This rectangle, when I do 2 times 26, I get 52. 52 minus 7 is 45. Okay, that makes life a lot better. So this rectangle is 3 by 30. This rectangle is 2 by 45. And they do both have the same area of 90. I guess the one nice thing about a word problem, and nice thing about algebra in general, is you do have a way to check your work, which was what I started doing, and I couldn't figure out what I did wrong. I am sorry. 12 plus 14 is most definitely 26. Next one, we are having a gym monthly sale where we can either pay $26 right at the start, and then every day we go, we're going to pay an extra dollar. Or you can just pay $6 every day you go and no initial fee. And we're trying to figure out basically how many times you're going to have to go to make it worth it. I do this all the time when I'm figuring out like things like pool passes or things like that. So one option is I'm paying 26 right away. But then every time I go, I'm paying $1. The other option is I'm just paying $6 every time I go. So let's first kind of look at that break-even point. What's that point when they're both the same? So if I subtract 1, x, I get 26. And I know you might be saying there, does she really need to write the 1x? I don't. I can just put x. Divide by 5. So I get an answer that is not quite right. I get not a whole number, so I get 5.2. That's like my break even point. Well, I can't go to the gym like 0.2 times. So what this is saying is like, when's it going to make it worth it to actually just take advantage of the membership? It's going to be after this. So what that means is if I go 6 visits, I'm much better off just buying this sale. If I go 5 visits or less, it's actually cheaper just to pay by the day. And that's going to happen at times with word problems is you're going to get something that's not a whole number. You kind of have to look at like the logics of it to see what makes sense. And finally, I pulled this one from a worksheet, and you probably have done things like this in a geometry class. So these two triangles have the same perimeter. I cut off the directions. The directions are basically what are the dimensions of the triangle. So perimeter is just adding up all the sides. So this side plus this side plus this side. Well, when I add all of them up, I have an x, an x, and an x. So if I add all my x's, I get 3x. And then I have a 5 and a 3, which is 8. This triangle, so this I'm just going to underline here and maybe see it easier. I have an x, a 2x, and another x, so that's 4x. And then I have a -1, a +1, those are going to cancel, and a 3. So I end up with just 3 for my constants. And in order to have the same perimeter, we just put an equal sign there. So now we're going to go through our solving, subtract 3x, subtract 3x. So we get 8 equals 1x or x. If you don't like writing the 1 in front, you do not have to. Minus 3, you get 5. One thing I like about word problems, real life problems, you don't end up with a lot of negatives. You don't end up with a lot of decimals. So I get 5. I want to see what the perimeters are. They should be the same, but I want to plug it back in and actually find the dimensions. So this first triangle, one side is 5, one side 5 plus 5 is 10, and one side 5 plus 3 is 8. This one, 5 minus 1 is 4, so one of my sides is 4. 2 times 5 is 10 plus 1 is 11, and 5 plus 3 is 8. So then I'm going to do a quick check. When I add these numbers up, do I get the same perimeter for both? This one has a perimeter of 23. This one has a perimeter of 23. Therefore, I have the exact same perimeter. So those are just some examples of how we can use equation solving either in real life problems or in what's called literal equations. Sorry, I made a couple of mistakes there early on, but hopefully that kind of shows you that we all make mistakes and we can go back and fix them, which is what I love about algebra.